So in a group of test results, how different are the values 80 and 90? Now, that all depends on the situation of how the whatever test was taken and how the marks were dispersed. So what we need to know is to answer this question is we need to learn about the distribution of data, meaning we need to know where the marks are located within the group that took the test. Now, we're going to redefine the term range. The range is the difference between the highest and lowest values within a set of numbers. And to calculate the range, we subtract the smallest number or the minimum number from the largest number in a set. And remember, we used the min and the max function in Excel in order to determine the range. And when we do that, we get an idea of whether or not there are any outliers located in the data. Now, if all the data were clustered around 85, with 80 and 90 at either extreme, in this case, an 80 would be very different than a 90, and here the range is 10. Now, in this case, a mark of 80 wouldn't be very good because it would be the lowest mark in the group, and mark of 90 would be very good because that would be the top mark in the group. On the other hand, if the range was from 40 up to 100, 80 and 90 wouldn't be all that different, even though 90 would be obviously better than the 80, but the 80 would be a significantly or a high mark within the group, according to this, unless the 40 was an outlier and the second highest mark was an 80. Then in that case, the marks would be very different. So we need to know how data is dispersed. So instead of range, a better method to determine if a mark is high or low is to consider the percentage of people with a score lower than yours in the class. So if you are interested in what percentile rank you are in, we are interested in what percent of the class had a lower mark than you. So as an example, if 65% of the scores were below 80, then a score of 80 would be in the 65th percentile. The mark in that case would be fairly good. However, if 10% of the scores in the class were below 80, then a score of 80 would be in the 10th percentile. And the mark of 80 in that case would not be very good. So if we take a look at, now this is a growth chart, and doctors quite often look at these as you're growing. And if we take a look at 17-year-old, and this is for boys from 2 to 20, if we take a look at the height of a 17-year-old, if you're in the 50th percentile, in other words, if 50% of the heights are below a certain value or above 50% or above a certain value, that would be at the median. And according to this growth chart, that would mean that if you're 175 centimeters tall at 17 years old, you are in the 50th percentile. By the same token, if you are in the 20th percentile, so if I move this down to the 20th percentile, then that means that you would be about 172 centimeters tall if you are in the 25th percentile. That means that 25% of the population would be shorter than you, 75% of the population would be taller than you. And the same idea goes with weight as well. So these percentile rankings are used quite a bit in medical to determine what the growth of a child. Now, some of the frequently used percentiles have specific names. Now, the median is the value that occupies the halfway position in an array, and so that means that the median is the 50th percentile. Quartiles are the values that occupy the quarter positions in an array. For example, the first quartile, Q1, is the 25th percentile. That means that at the 25th percentile, 25% of the values are below that value, and 75% of the values would be above that value. At the third quartile, Q3, that's the 75th percentile, and that means that 75% of the values are below the value at the third quartile, and 25% of the values would be above that value at the third quartile. Now, as far as the second quartile, we call that Q2, and that's the 50th percentile or the median. Now, as far as calculating the value or the position number of a particular percentile, if we order numbers in an array, then what we can do is use this formula in order to determine the position of a particular percentile. So the position number of X percentiles, so let's say X is 50 within an array, then it's given by N plus 1 divided by 100 times X, where X represents a percentile and N represents the number of values in the array. Now just to give an example, what is the position number of the 50th percentile if there are 9 values in the array? So in this case, N is equal to 9, X is equal to 50. So that means that the position number of X, the position is going to be N plus 1 over 100 times X is our formula. So when we sub in, it's going to be 9 plus 1 over 100 times 50, which is equal to 5. Now, that makes sense because if you have 9 values in an array, the median, which is the 50th percentile, is going to be half the middle value. So the 5th value will have 4 values below it and 4 values above it. And so that fits in with our definition of median as well as a 50th percentile. By the same token, if we want to know what the 50th percentile is for an array with 99 values, well, N plus 1 over 100 times 50, and in this case, and I should actually use the formula, so I'm going to use X here. So this is equal to 99 plus 1 all over 100 times 50. And so this is equal to 100 divided by 100 times 50, which is 50. So that if we have 99 values, then the position number, the 50th value in our array, if we order them from least to greatest, will be our median and will be the 50th percentile. And that means that at the 50th position, there's going to be 49 values below, 49 values above. So that means that that's going to be the median or the 50th percentile. So now what I want you to do is use the formula to determine the position of the median, given that we have 22 manufacturers and we're looking at the number of calories in these ice cream bars. So what I want you to do is identify the position and the value of the median in this group of data using the formula we used previously, and then check back with your answer.